All right, we got points negative 2, 4, and we've got 0.2, which is 6, 5. Now, what I'm going to do is this one asks only for the distance, but I'm going to find the midpoint and distance, considering the fact that you might have a question that asks for the midpoint instead. So if we want to find the midpoint, if you'll remember, that was this formula. You have x1 plus x2 over 2, comma, y1 plus y2 over 2. All right. And so to find the midpoint between the two, remember we're finding points that are halfway between both. So you end up with -2 plus 6 over 2, and you'll end up with 4 plus 5 over 2 in this particular situation. -2 over plus 6 is going to be 4. 4 over 2 is 2. And then 4 plus 5 is 9. 9 over 2 is 4.5. So that would be your midpoint. Now, distance actually uses the Pythagorean theorem. Basically, the idea is this: if you have this point 1 down here and this point 2 over here, then if I want to find the distance between these 2 points, I can use the change in y values over the change in x values. And the way we do that is with this formula. You can write this formula down. Basically, it's going to be, y2 minus y1, or x2 minus x1 squared plus x2 minus x1 squared. Does it matter which one comes first? No. Just as long as it's consistent. Consistent. All right. So in other words, if you're saying y2 is 5, well then x2 needs to be 6. So just make sure that you're keeping everything consistent. All right. The other thing is this. All this means is the difference between the two. So what I'm saying is, like, for example, the difference between my y values is 1. The difference between my x values is 8. Real simple. In other words, from 4 to 5 is 1, right? Y'all see what I'm saying? From -2 to 6 is 8. That's all I'm saying there. And then this ends up being square root of 1 plus 64, or the square root of 65. And it wants to answer. Please note what answer it's asking for, because if you plug square root of 65 into your calculator and give that, it won't accept that as an answer. Y'all see what I'm saying? You want to make sure that you actually find out what the thing is asking you for. It's asking you for a radical answer, square root of 65. Questions? Y'all see what I'm saying, right? All right. Okay, there's that. This next one asks for the midpoint, so we're going to skip that one. Find the center and radius of the following. I think I'm going to try to close this. Oh, there we go. Okay, there we go. We can actually see now. All right, find the center and radius of the circle, right? The standard form of the equation. So this should be real simple. The center is at -3, -2. So that's what we're going to type in. And the radius of the circle, well, if we could just count, basically you can see that these are going by ones. You can kind of check that by looking at the tick marks. So like 2, for example, is on to the second tick mark. Be careful, make sure your scale is correct. So you end up with like 1, 2, it looks like 1, 2, 3. There's a 3 between the center and the tip. So the radius of the circle is 3. Real simple. Oh, let's see. All right, the equation of the circle in standard form. Standard form, our equations are going to be x minus h squared plus y minus k squared is equal to r squared, right? Where h and k are your centers. So basically we got x minus h, that's going to be x plus 3 in this situation, squared. And then plus y minus k is going to give you y plus 2 squared equals 9. And that's it. I'm gonna give you a minute to work on your own problem. Just make sure that you got it. If you want to move on to the next problem and practice that, but I'm just gonna give everybody like 60 seconds to kind of work on that real quick. So make sure that you have time to actually put it into practice. I believe this one, you don't have to wait till the very end to find out if it's right or not. Also, this is the final exam is worth 20 points bonus. So if you complete however much of the final exam practice review you get, that's bonus points. You get 20 bonus points for completing the practice exam, or rather say up to. Yes, you can get up to 20. So like if you get half, it'd be 10. This is some extra added incentive. All right. This is kind of well, no, it's not. All right, let's walk through this. So we've got the standard form of the equation and the general form of the equation of the circle with radius, this stuff. All right, so the first thing we're going to do is the standard form of the equation of the circle would be what we would normally do. Basically, x minus h, so in this case, x minus 3 squared, y minus k, so plus y plus 4 in this case. It's plus 4 because our radius is negative 4. You got a negative 4 here, so it's y plus 4. And we're going to square it equals r squared 25. Please make sure you remember to square the last part. People that's the number one thing people forget to do. So just say equals 5. So be careful about that. All right, to actually turn it into general form, we actually have to do a little math. So we're going to have x minus 3 squared, which if you'll remember is the same thing as x minus 3 times x minus 3. Now, according to our word thing we've been doing all year, completing the square, what you should note is that you'll start with x squared, and then you multiply x times negative 3. In other words, these two together. But do that, you actually end up doing it twice. You end up doing it once here, and you end up doing it once here. So you just do negative 6x plus, and then the last 2 squared. And that's it. That's kind of the quick way of squaring these things. So what will y plus 4 squared look like? Y squared, yeah, plus 8y, yeah, and then plus 16. Real simple. You don't have to actually write it all the way out and multiply everything out. It's just a real quick way to do it. Yeah. All right, and then it's equal to 25. Now, what we want is we want everything on one side, basically. We want everything on one side. We'll put the squares first, then the linear terms, and then some number. So what we're going to do is we're going to say x squared plus y squared first. Then we're going to do minus 6x plus 8y, our linear terms next. Then if you'll look at it, you end up with 9 plus 16, that gives you 25. But if I subtract 25 on both sides, that gives me 0. So that's it. We'll do x squared plus y squared minus 6x plus 8y equals 0. And we're going to graph this thing. We've got a center at 3, negative 4. 1, 2, 3, 4, 5. All right, I'm gonna give y'all a minute. I'm gonna walk around. I want to make sure, because there's a couple of things on here that I think are important. So make sure that you can get it. So I'm gonna walk around, try to help you out if I can. done with this problem, work on another problem. So we find the goal is to get you guys through the problem. Did I send an announcement saying bring your computers? I did. I want to make sure I went right. Gotta check. Yeah, but if you didn't bring your computer, you can actually pull up my math lab on your phone if you have the Canvas app. I found that out this weekend. I was literally driving. People were like, could you open this? Could you open this, please, please, please? I'm like, I'm on the road. All right, well, I'll risk my health and safety because you need to take this test right now. The things I do for y'all. The things I do for y'all. All right, we good? You good on that? Yes, yes. Seeing a couple yeses. Good. All right, I think we're gonna move on. All right, this kind of similar-ish, so I'm gonna skip that one. This one has a part of it where you're going from general form to standard. Now, if we're going from general form to standard, ooh. Okay, let's do this problem. All right, so we got x squared. Y'all see what I see in a minute. X squared plus y squared plus 3x plus 4y plus 4 is equal to 0. Now we know how to get from general to standard form. We've done it quite a few times, but we're going to practice. The first thing we're going to do is get your x's together, get your y's together. You're going to with x squared plus 3x and then plus y squared plus 4y is equal to -4. Get your x's together, your y's together, and put the numbers on the other side. Does this kind of ring a bell? Hopefully. We did it a lot. All right, so here's the problem that I found. The problem with this is the number 3 right here is odd. So I'm going to deal with that second. First thing I'm going to do is I'm going to deal with y squared plus 4y. Does anybody remember one of the 2 main steps to completing the square? Having something to do with b value. Yeah, so you take your b value, in this case, our b value is 4, and you divide it by 2, so that's the first part. Then you square it, exactly. You take the 2, then you square it, you get 4. Sure, that felt like that was a long time ago, but that's what we do. Now you probably can see what's the problem with the x value, but that should not deter us because, you know, we're not afraid of fractions. We're in it with 3/2, which is going to give us just 3/2, or, you know, 1.5, if you will. But we could actually just use 3/2. It's fine. It wants it as integers or fractions, so let's keep it as 3/2, shall we? And then if we do 3/2 squared, the way you square a fraction is you use the you square the numerator and then square the denominator. So you know with 9/4. So you can see it's not that bad. It's not awful, but it's just not fun either. So now what we're going to do is we're going to add to both sides. So we're going to have x squared plus 3x plus 9/4 plus y squared plus 4y plus 4 equals -4. But now on the end of this -4, we need to add these two values. Remember, we got to balance it out. So +4 and plus 9/4. Right? Because whatever we add to one side of the equation, we have to add to the other side. Everybody follow me so far? Okay, impressive. All right, so now what we're gonna do is we're gonna use the value that we got first from the b over 2 to synthesize these or bring these closer together, or simplify them. I didn't say synthesize. Simplify these two things. For the first one, we're in it with y plus 2 squared. Why is it y plus 2 squared? Because this number was 2. Everybody see that? Whatever this number is, your b over 2 is, that's what we synthesize it down to, or I keep saying synthesize. Simplify it down to. Same thing over here. So that said, it should be x plus what? 3 over 2, exactly right. Exactly so. We're gonna have plus, the 4's cancel on the right, so you end up with 9 over 4. That's it. Yes, straight up. Okay, so what I did is I took, remember we added 4 over here? So I added 4 over here. We had just y squared plus 4y, and then we add this 4 to that. So if I add 4 to one side of the equation, I have to add it to the other side of the equation. That's what the 4 came from. Same thing with the 9 over 4. This 9 over 4 comes, it was right here. Add it to this side, have to add it to this side. All right, so let's answer the questions. The first thing we're told is, what is the center? The center of the equation ends up being negative 3 over 2, negative 2. All of our values were positive, so when we actually input them, they need to be negative. Then what we need to do is we're going to plug in, for the radius of the circle is the square root of 9 over 4. Well, we kind of know what that is. It's 3 over 2. All right, square root of 9 is 3. Square root of 4 is 2. And then we're going to see if we can't figure this part out. All right, we need 3, negative 3.5, which is negative like 1.5, and then negative 2. That puts that right about there. And we need the radius to be 3.5, which gets us here. All right, so 1/2, 2/2, 3/2. We're gonna hit save. The intercepts are, well, there's only one. It's going to be at 0, -2. That's the only place where you hit any axis. And we're checking our answer. And ooh, I know what I'm doing. All right, any questions on that one? All right, we're on problem 6. We're almost 1/10 of the way through. We're more than 1/10 of the way through. So we're killing it out here. All right, center at the origin containing the point, -5, 7. The reason I'm trying to spend a little bit more time at the front end is because this is stuff that I'm sure some of y'all have forgotten how to do. Okay, so I'm kind of assuming that the back end, y'all kind of know how to do a lot of that ish, but I want to make sure that the front end stuff is, you don't miss the easy stuff is the main thing. All right, so the center is at the origin. That means your center is at what point? 0, 0. Now it contains the point, so that means that your circle will actually have the point -5, 7 on it. So in other words, you think about, ooh, that looks like it. But if you think about this, you can think about, okay, the center is going to be here at 0, 0, and then you're going to go -5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. This point out here is going to be on your circle. So that kind of is the visual there. It's not a circle, but you get the idea. All right, so the first thing, there's two main things you need to know to create an equation for a circle. You need to figure out what the center is, but you also need to know what the radius is. And so to find the radius, we can once again think of this as a Pythagorean theorem problem. All right. Why? Because we're finding the distance between 2 points. This point and this point. Y'all see what I'm saying? We're literally, it's the distance formula again. So what we can say is the distance is going to be equal to the square root of, let's see, x2 minus x1, that's going to be -5 minus 0 squared, plus y2 minus y1, that's going to be 7 minus 0 squared. If I plug all that in, you end up with -5 squared plus 7 squared, which gives you the square root of 25 plus 49, which gives you the square root of 74. So that's R. Now, remember that the general formula is x minus h squared plus y minus k squared, but it's equal to r squared, not r, equal to r squared. So the way I would set this up is I would say x minus 0 squared, because that's your center value, y minus 0 squared is equal to the square root of 74. But let's think about it. We're actually squaring that value. We're actually going to square that value. So what does that mean? If I put this all together, you end up with x squared plus y squared equals 74, because the square root and the square actually cancel each other out. So the square root of 74, and then I square it, it's canceled out. So if I put all this in, let's check and make sure that I'm doing it correctly. X squared plus y squared equals 74. And yeah. Tangent to the x-axis just means that it touches the x-axis. So, I mean, you can still come up with that. Endpoints of the diameter. All you do is figure out the distance between these 2 points and then cut it in half so that you can find your radius. All right, let's talk about domain. Remember, values inside of a square root cannot be negative, right? Values inside a square root can't be negative. So basically, here's what has to be true about the domain here. The domain has to occur for this problem where 2x minus 12 is greater than or equal to 0. Everybody understand why, right? If you end up with a square root of a negative number, there's no dice. So what we're going to do is we're going to solve this just like we would solve any other inequality. We're going to add 12 to both sides, and you divide by 2 on both sides. When is the one and only time that we change the sign on an inequality? Yeah, divide or multiply by a negative number. That's the only time you would change the sign. So the domain is that x is greater than or equal to 6. Therefore, what we're going to do is use a bracket, 6, comma, infinity. We use a bracket because we can't include 6. 6 will give us 6 times 2 is 12. 12 minus 12 is 0. You can have the square root of 0, that's fine. So we're going to include that value in this particular situation. We use bracket, 6, comma, infinity, parentheses, check, yes. All right, let's walk through this one. Same idea, but there's an extra wrinkle here. The extra wrinkle is the fact that I actually can't include 0 as a value here. Why can't I include 0 as a potential value. We could include 0 before, but we can't include 0 now. Because what happens if x plus 8 is 0? Undefined, exactly. So in this case, not only do we need it to be greater than or equal to 0, we need it to be greater than strictly only than 0. We need it to be just greater than 0. All right, so what we're going to do is subtract 8 on both sides when the x is greater than -8. So our domain is going to be completely in parentheses. We're going to have -8 on one side and then to infinity and beyond. Questions? Okay, I'm gonna leave the rest of those alone. These is real simple. All you do is look at the x values and give me the y values. So like, for example, he said find f of -21. Well, at -21, the y value is -2. That's the answer. At -6, the y value is 2. That's your answer. At f of 18, your y value is 2. And at f of 0, your y value is -1. I'm just looking at the things, whatnot. All right. Is f of 6 positive or negative? Well, 6 is right here. It's your x value. Your input is 6. When your input 6, your output's -2, so it's negative. Is f of -9 positive, negative? Well, let's look at -9. -9 is over here. When I input -9, I output a +3, so it's positive. For what values of x is f of x equal to 0? That's here at -18, or f of x equals 0, my bad. So f of x equal to 0 means where is y equal to 0? That occurs right here, the y-intercept at x equals oops, I'm sorry, hold on. My bad. F of x equals 0 means y equals 0, which is here, here, and here. All I had to do is look at the last points bit. Just look at the last point. All right, so that occurs at -18, -3, and 12. So -18, -3, comma, and 12. For what values of x is f of x greater than 0? Well, you're greater than 0, whenever I'm above the x-axis. So that occurs between -18 and -3. Parentheses. Oh, they want a compound inequality. They don't want interval notation. Okay, so we got to read. We got -18 greater than x, greater than, and then we're going to do less than -3. Then we're going to hit a comma, and then we're going to have between 12 and 18 as well. So we're going to do 12, this x, this 18, because it's here and here is what I'm talking about. What is the domain? The lowest we can go is -21, and the highest we can go is 18. So the domain as a compound inequality is going to be -21, comma, less than x, less than 18. And then in this particular instance, the range, the lowest value you can get is -2, and the range and the highest value it seems like you get is 3. So basically we're going to say -2 less than y less than 3. The intercepts, the x-intercepts occur at those same spots, -18, -3, 12, assuming that is asking the same question. Y-intercept, there's only one at -1. Dang, this problem's long. All right, how often does y equals 1 intersect the graph? Well, what you can do kind of in your mind is draw this imaginary line at y equals 1 and kind of see where does it hit the graph. Well, it's hit 3 times. How often does the line x equals 5 intercept the graph? Well, if it's a function, it only should hit once, but let's check and make sure. Yep, 1 time. M, at some point, don't you need to start another question? All right, for what values of x does f of x equal -2? Okay, well, it's at 2 different values, at -21 and at 6. Those are the 2 spots where your y value, your output is -2. 4 values is at 3, that's only 1, -9. Okay, what are the zeros of this thing? How many different ways can they ask this question about x-intercepts? It's 3 different ways. Okay, all right. And what did I do wrong? It's not gonna tell me? All right. Let me see if I can figure out what I did. Oh, that's right. Values of x is f of x equal to 0. Yeah, no, they asked the same question 3 times. What are the x-intercepts? What are the y-intercepts? Is y equals -. Here, 21, 6. 1 time. Y-intercepts. Set as a compound inequality. I don't see. Let's see what. -2. -6. 2. F of 0. -1. Positive, negative. Yeah, I might have to, because I don't want you all to oh, I know what I did wrong. Okay, so I should have included these values. So I should use greater than or equal to, because they are actually a part of the domain. So I think that's what I messed up at. Let's see if I'm right. Yep. All right, so moral of the story, be careful. Make sure that we include the values that need to be included, and we're going to do that with greater than or equal to. So yeah. Okay. Intervals that are decreasing, everybody should be okay with that. The only issue that I have with this thing is that when they're using decreasing intervals, usually you want to use brackets instead of parentheses, which doesn't make any sense to me whatsoever, but use brackets in that case. Use the graph of the function f, given below to answer the questions. Local max, local min. I'm not going to go through this, but remember, local maximum means it's like at the top of the hill. Remember, minimums mean the bottom of the value. I remember that. All right, so yeah, that's local max and min. Determine algebraically whether the function is even, odd, or neither. All right, so it's 3 things that we need to know. Basically, if f of x is equal to f of -x, this is even. All right. And the best way to tell that is, honestly, is just pick some values. Like, for example, pick the 2 values, 1 and -1, and plug them in and see if you get the same thing. If you do get the same thing, it's even. If you don't, well, if you get negatives of each other, so in other words, if f of x is equal to -f of -x, In other words, like for example, if you have something like, you know, x cubed, y equals x cubed. This is an odd function, but if I plug -1 in for y, you'll notice that y is equal to -1. Actually, 1 and -1 aren't good examples of this. So let's use use anything other than 1 and -1. Probably a 2, -2 too. Let's use -3. So if I plug -3 into this, you can plug that into your calculator. Just make sure you put the parentheses around it. You know, with -27. If I plug +3 into this, y equals 3 cubed, you'll end up with y is equal to 27. You'll notice that these two are not the same, but one is the negative of the other. So this is odd. Y'all see what I'm saying? So if they're the exact same, even. If one's the negative of the other one, odd. And if it's neither, it's neither. So you'll find that in this particular instance. You can do 9 to the 3rd cube. That's going to give you 81. Oh, no, it's more than 81. It's 27 times 9, which is going to be 700. Ugh, 27 times 9. Nope. 20 is going to be 180 plus 63, so 243. I'm about to say that's too big. So 250. But if I use -3 cubed, you're going to end up with -243 plus 7, which is going to be -236. So these two are obviously not anywhere near being like each other. Does that make sense? So your answer is going to be neither. Match the graphs of the functions. We've done this quite a few times, so I would just practice those. Remember, absolute value function, V, absolute value V, looks like a V. Absolute value. All right, find the function that is finally graphed. What? Oh, find the function that is finally graphed after the following transformations are applied to the graph y equals x square root of x in the order listed. All right, so we're going to reflect about the x-axis. All right, so there's a few things that we need to do. We're reflecting about the x-axis. That means there needs to be a negative on the y value. You know, a negative y is equal to the square root of x, but because we need y to still be equal to something, we end up with y equals -√x. Okay, so that's the first thing. We did the first thing. The second thing we need to do is shift down 6 units. Shift down 6 units. That means we're going to subtract from the inside of the function or the outside. We're shifting down. Outside. Shift down. So -6 on the outside. But we're going to shift right 4 units. Right 4 units. So we're going to end up with y is equal to -√x plus 4 on the inside. And then, yeah. So I'm going to give you a minute because this one, it pops up a few times. So I'm going to give you a minute. I want you to work through one that what is like it. As always, if you've already finished this particular problem and you want to move on to another problem that you want to practice on, you definitely can, but I'm going to give everybody a minute to work on one like this. Shifting down, right, left, reflecting around the x-axis or the y-axis. All these are things that are bound to come up. Note, and just a side note, if it told me to reflect about the y-axis instead of putting the negative on the y, I would put the negative on the x. I'd have something like y equals square root of -x. So be careful about that. Oh, we need minus 4, not plus 4. Minus 4 because left and right is opposite. So you shift right, minus 4. You shift left, it should be plus 4. All right, so here's kind of my thought process right now. So I want to go through maybe 5 or 10 more questions in the next like 10 minutes. So I'm going to go kind of fast-ish, but I want to cover quite a little bit of space because ain't no way I'm going to get to even halfway if I don't. What I'll do is I have office hours on Fridays as normal, but I'll record it this time and try to finish this and post it. See how I'll have that. Okay. So even if nobody shows up, I'm going to try to do that. But please show up because that way, if you have specific questions that somebody else might have, I can get those answered. You know, see what I'm saying? But it'll be Friday at the normal time, which is 5:30. And I'll record it and everything. All right, I'm gonna go quick. The first thing I'm gonna do is I'm gonna say, okay, to figure out the y-intercept occurs when x equals 0. All right, so what we're gonna do is we're gonna say, okay, I want f of 0 in this particular situation. That's what this is literally asking me. And that's gonna be 0 squared minus 2 times 0 minus 8, or basically just negative 8, because everything else is gonna be 0. So I'm gonna plug that in, boom, y-intercept, negative 8. Determine. Oh, now we got to graph it? Okay. Oh, I missed some stuff. Oh, yeah. Oh, how did I miss all that? Okay. All right, let's walk through this. Does it open up and down or down? Up, because you have x squared is positive, so it's up. What are the coordinates of the vertex? Oh, Lord. Remember, that is the negative b over 2a piece. Y'all remember that? So yeah, so we need so we need negative b, which would be negative 2 over 2 times 1. That's going to give us positive 2 over 2, which gives us 1. All right, and then we take that's our x value, we plug that into the parabola. So f of 1 is going to be 1 squared minus 2 times 1 minus 8. It's going to give us 1 minus 2 minus 8, or negative 9. So our value should be 1, negative 9 is your vertex. That's a 0. All right. What's the axis of symmetry? X equals 1. We did that. Okay. Let me see. X-intercepts. X-intercepts occur when y equals 0. So what we're going to do is we're going to say, okay, I've got 0 is equal to x squared minus 2x minus 8. What can I reduce this down to? Or factor it to, rather. Yeah, x minus 4, x plus 2. So the two values, the intercepts are going to be 2 -2 rather, and +4. All right, now then y-intercept. All right, and we're going to take all this information that we found, the fact that our vertex, what was that, 1, -2? I don't even remember. That's not good. Okay. -2 and 4, x symmetry, 1, -9. Okay, probably should have written all that down, but anyway. 1, -9. So 1, -9. Okay, and 2 and 4, I think, were what we had. Yeah, -2 and 4. The domain, the lowest is from -infinity to +infinity. There's basically no restrictions on this one. It's +infinity. The range, the lowest value you can get is -9. So what we're going to say is it is from interval notation. So we went -9 to infinity. Let me see. Function is increasing on the interval from 1 to infinity. It's going up on the right side, basically, and it's going down from -infinity to 1. Well, yeah, but -9, I agree, is the lowest, but when we're talking about intervals, we're only talking about the x values. Yeah. And yeah, what I did wrong. I don't like it doesn't tell you what you did wrong. Vertex, the parabola is 1, -9. Obviously, all that has to be correct. Y-intercept is -8. Range. What to do? Oh, no. Because 1 squared is 1, and then -2 is -1. -8 is -9. So oh. That's stupid. Ah, man. All right. This thing is touchy. This thing is touchy. All right. Yeah, one more reason to actually go through the whole thing and practice and see exactly what it's asking for at specific values. Obviously, for the minimum value, you're going to use -b/2a to figure out where the x value is and then plug it in and determine if it's a max or a min. In this particular situation, since it's opening up, then you should have a minimum value. In this case, it would be a maximum value because this is opening down. So I have a maximum value. This is a R equal a P problem. Solving the inequalities, remember that is factoring it out and then using the number lines. Y'all remember that? Using the number lines. That's how you're going to solve those. Another P problem. Trying to get to something that's a little bit different. These shouldn't be too hard to graph. So like, for example, what kind of transition has this made? If you have x plus 9 on the inside, what kind of transition does that mean? You go up, down, left, right. What do we do? Left, 9. In this case, we got x to the 5th minus 6 on the outside. So where we're going, left, right, up, down, where we're going? Down 6. Exactly. Ooh, zeros with multiplicities. So this one, to find a polynomial with this particular degree, is we're going to have, so for example, we got a 0, 1 with a multiplicity of 1. So you're going to use x minus 1. 0, 3 with a multiplicity of 2. So you have x minus 3 squared. And it's the degree 3. So we're just multiply it out. You end up with x minus 3 squared, which is really nice because we can kind of use our trick to figure out what this should be. And you'll end up with x squared minus 6x plus 9. Remember, 2 times the middle. And then you multiply it out. You end up with x cubed minus 6x squared plus 9x. If you multiply x by all 3 of these terms, if you multiply -1 by all 3 terms, you get negative x squared plus 6x minus 9, which gives you x cubed minus 7x squared plus 15x minus 9. And y'all thought it was going to be scary. Y'all looking at me like, Mr. Brooks, that is scary. What are you talking about? X cubed. But yeah, this is the other reason why I wanted to plug these in on the spot, because I want to make sure that as you all are practicing, you know how to kind of, I guess, troubleshoot and figure out how to fix what you might be missing or whatever. All right, guys. So I'm going to stop it there.